Let's write the actual JavaScript code for our square of squares example. I have a CodePen opened up and I've gotten a start on the code, so please follow along with me if you will. If I'm going to go relatively quickly over the code that's already here. Feel free to pause the video whenever you like to, if you're writing your own version of this so you can catch up. So let's start with the HTML. Pretty straightforward here. I've made just a header here for the square of squares, and then we've created a canvas element. We discussed this during our previous lecture. If you missed that lecture, we'll talk about this enough so that you'll understand what's going on in this lecture. So canvas is just a HTML element that you can draw pictures on. Okay, like a painting canvas. All right, and then down below the canvas in a div, I placed a label, this in here, and then just a text edit so I can write how many squares I want. So if I put it here, it'd be a 6 by 6 square that I draw. All right, with a numeric input, minimum of 1, with the ID in. That's how we'll access it through the JavaScript code. And also a button, so nothing's going to happen. We're not going to do this on a change, but we're going to do it on a button click. So when someone types the draw square button, then we'll actually draw the square of squares up here in the canvas. Okay, so the HTML is pretty straightforward. The CSS, not very much here either, just completing the look of the canvas here. We made it a 480 pixel by 480 pixel canvas with a solid blue border, so we can see it without putting the border here. It will be white on white and you can't see where the canvas is specifically. Okay, now so the bulk of our work is going to be here in JavaScript. So I guess remember here from the HTML, the two IDs that we need to know are that the input had ID in and our draw square button had the ID draw. Okay, so in our JavaScript, notice at the bottom first I've added our connector here that hooks up our draw square button to this draw square function. So when the element with ID draw is clicked, we call the draw square function. Okay, draw square. By the way, if you look up the JavaScript tools, I have included jQuery. We're going to be using jQuery here. If you saw the previous lecture on canvases, you will have discovered that jQuery does not directly interact with canvases. So we have to use the older style here of document.getElementById, which is just a built-in function, which does the same thing as using the $ and the selector in jQuery. So anyway, this puts the canvas object into a variable called canvas. This is new, the next 4 lines of code. We saw when looking at the canvas earlier that most of our monitors had an effect where the vertical pixels were twice as large as the horizontal pixels, that gave us kind of a skewed view when we printed things. So like if we made a 10 by 10 square, it would look more like a stretched out rectangle. Okay, well this has something to do with something called device pixel ratio. And basically it's for high resolution devices. Some tricks that manufacturers have done to get higher resolution is to no longer have a single pixel, a logical pixel correspond to a physical pixel on the screen. So this is just a little trick here, which you don't have to know this for any testing purposes, but I have it here just to help us out. We didn't do this last time, but I just said let DPR get window.devicePixelRatio. Window is a built-in object in JavaScript which refers to the HTML window from your browser. And there are some built-in attributes. One is device pixel ratio, which will tell you, how how stretched out the pixels are, basically, how many actual pixels are in a logical pixel. Okay, so we get that, and we also get what's called the bounding client rectangle. So that's how big this viewport is basically on the web screen. And then we set the width and the height of the canvas to match the actual pixels, right? So we get the device pixel ratio and multiply it by the existing width and height of the canvas, which was 480 by 480, and whatever this DPR is, and now we'll make, basically this makes it so that if we just use our logical pixels, you know, we make a 1 by 1 square, it will actually be 1 pixel by 1 pixel, and it'll be in the right dimensions. Okay, so don't worry too much about the math here, but it's just a trick to make our coding easy, so we don't have to manually double all of our y coordinates to make it, or have all our y coordinates to make them line up. Okay, anyway, as before, we'll get a context off of the canvas, 2D or 3D. We're doing 2D here. This is what we're going to interact with. The final step in making our pixel ratio work here is to scale both the x-axis, that's the first parameter, and the y-axis. This is just a multiplier, okay? And again, it's going to make it so that our logical pixels match our physical pixels. Okay, at this point where the cursor is here, nothing special going on, all right? So we're just going to start interacting directly with the context, which is variable c at this point. This will be like we've done before. Okay, so what I'm going to do is, first of all, just get this number off of the numeric input, okay? So this is the type of code that you might need to know for doing assignments and exam problems in the future. I'll give you all this code here if this is ever like an exam problem, or just assume that it's done. All right, so anyway, here we go. I'll say let n get number, and now I'll use my jQuery. Let's get that element that has ID n. Remember, that was the numeric input. And we'll grab a value out of there. As you remember from earlier examples, the val function always returns a string. We want this to be a number, so we manually convert it into a number with a number function. Okay. Now we know how many rectangles we need, how many rows we need, how many columns we need of these squares. Okay, that will help us with our loops. Now, just to get things going a little bit, we'll use that context and do a clear rect. Clear a rectangle. This is basically erasing anything from a rectangle on the canvas. We give it a starting point. We learned before that our coordinate system starts at 0, 0 up in the upper left-hand corner. So in clear rect, we say give a starting x position, 0, a starting y position, 0. Follow that with the width and height of the rectangle we want to clear. So in this case, we'll say 480 by 480. If you recall, that's what we set the dimensions of the canvas to in our CSS file, right? All right, so this will just erase whatever's there. Basically, this allows us to hit draw square a second time. It will erase whatever's there the first time, and we'll start from a clean slate each time through. Okay, now we will also, from that same context, put in a fill style. Okay, we're going to be drawing rectangles. If we just draw them by default, they'll make just kind of white rectangles with a border. I want these to be filled, and so this is where I can give, oh, it's not a function actually, you just set a value. I can give a color here. Let me do red just to make it kind of stand out a bit. Okay, that's kind of it. Now, what I'd like to do is set a couple of constants. Okay, remember the const keyword allows us to set variables that we don't intend to change. So I'm going to say const size, and let's just say that our squares are going to be 20 by 20 pixels. All right, so I can put this in a variable. If I don't do this, I'm going to have to sort of use the number 20 directly in my code, which is sort of a magic number. If I refer to the variable size, I can go back to this one point of code and change it from 20 to 30. It will automatically change below when I refer to size. That's, we're kind of isolating our assumption here that the width and height of the square is 20 pixels. Okay, what I'm going to do is like we saw on the PowerPoint, we'll print a square, give myself a little space, and print another square, give myself a little space. I need to know how big that space is. All right, so that's going to be another constant, which I'm going to call gap. And I'm going to set this to 4 pixels. You can play around with this to see what looks best. But so as now it's going to be my square is going to be 20 by 20, and in between each 20 by 20 square, I'll have 4 pixels of space, especially on the x-axis as I go across. Okay, very good. Now, the code I'm going to write here, it will look most like what we did in the PowerPoint presentation earlier. We're going to have an outer loop for let I get 1, I is less than or equal to n, I plus plus. Okay, basically that's our outer loop. It helps us to print n rows. Okay, now to print each row we have to have an inner loop inside of here. That will be for let j get 1, j is less than or equal to n j plus plus. All right, so exactly like we did before. Before here we just said print a row or print a square. Now we got to actually print the square. It's a one-liner, but we have to kind of mess around with math here a little bit. Okay, so from the context, which was the variable c, instead of doing a clear rect, we'll do a fill rect. Fill a rectangle. It works the same way as clear rect. You give an x value and a y value of where you're going to place the rectangle. So 0, 0 would be in the upper left-hand corner. It goes positive down the y-axis, positive across the x-axis. So if I said, for example, 2020, it would say go across 20 pixels on the x-axis, go down 20 pixels on the right axis. That would be the upper left-hand corner of my first square, which I could draw like right here. Okay, so what should I do here? We got to kind of think of what the I and the J are referring to. The I is going to say, that's row by row, so that's going to say when I is 1, we'll be drawing our first row. When I is 2, we'll be drawing our second row. 3 is our third row. 4 is our fourth row. Okay, so even though the rows, the I value is telling us how far down to go, right? Because like the whole first iteration of the outer loop, I'm going to be going across the x-axis this way. So my I value is going to tell me how far down the y-axis I have to go. All right, so that's going to be actually my second parameter. Remember, x value, then y value. So my inner loop, as I'm on the first row, as I is 1, j is going to be 1, 2, 3, 4, representing which square I print. So actually, my x value is more tied to j in this example. All right. So if I put in here j as my x value, well, that would just say, okay, j is going to be 1, 2, 3, and 4. So it would actually, on the x-axis, we'd put the first rectangle here at 1, the second rectangle at 2 would just be 1 pixel over, the third at 3, and the fourth at 4. So we could certainly do that, but the rectangles are going to be 20 pixels wide, so there'd be a lot of overlap there. So really we have to compute how far down to go, okay? So what I'm going to do is instead of just saying j, I'm going to say j times, well, let me do it this way first. Size, let's see what that will do. Okay, if I say j times size, again, j is going to be 1, 2, 3, 4. Size is 20, so that would mean 1 times 20. That would mean the first rectangle would start 20 pixels over, right? And the second rectangle would be when j was 2, it'd be 2 times 20, so that would start at 40. Now the deal here is, when I start the first rectangle at position 20, it's 20 wide, so it will end right at 40. And so as the code stands now, my second one would start at 40 and go to 60. My third one would start at 60 and go to 80, and then 80 to 100. And if you think about it, where one rectangle ends, the next rectangle will begin. They'll be right next to each other. You won't even see that they're different rectangles. All right. So I'm going to go ahead and code it out this way so we can kind of see how it works. But we're going to have to add, you're going to have to do a little bit more work with that. That's why I made the gap up here. We'll add that in later. All right. So anyway, there it is. Now the second one is where we start on the y-axis, all right? And that's what I said would be 1, 2, 3, 4, right? For I, again, if it was just I, it would be 1, 2, 3, 4, all up at the top. So just like we did here, we're going to say I times size, okay? And that'd mean instead of starting at 1, 2, 3, 4, we'd start at 1 times 20, which would be 20, and then 2 times 20, which is 40, 3 times 20 is 60, 4 times 20, 80. Still the same problem. They're exactly 20 wide, and so they'll be right up next to each other. But we'll expect that to happen. So now with that there, and then we want to give the actual dimensions, how wide it is, how tall it is. Well, that's our size. Since they're squares, they'll be the same. So we'll say size pixels wide and size pixels high. There we go. And believe it or not, that does it, okay? Because we already have our loop set up to change I and j. Okay, so this is basically our draw square that we had in the PowerPoint. All right, so that'll do it. No new lines or anything, because we're controlling that with the I parameter. So let's test it here. Let's say a 4. We draw our square. Okay, now it makes one big square, but this is exactly what I was telling you. It's going to be one square here, a second square here, a third square, and a fourth square. They're just all next to each other. We can kind of see if this works a little dynamically. Change this from 4 to say 10. Now I still have 20 by 20 squares, but I have more of them, so it just makes a bigger square. So it kind of works to some degree. Okay, so what we want to do here is just add in this gap. Okay, and what that's going to mean is, well, as I'm printing these 10 squares, I don't want to just print the square. I want to print the square and a 4 pixel gap and then start my next one. So each beginning point will not just be size-wise, but size plus that 4 pixel gap. All right, so instead of 20 pixels wide, it's going to be 24. So I hope you can see that's going to be, for my X position, I'm going to say j times not just size, but size plus gap. And truly, it's going to be the same going down because it's 20 high and then a 4 pixel gap, and then another 20 and a 4 pixel gap. So instead of I times size, it would be I times size plus gap. I still want them to be 20 by 20, so the width and the height should stay size and size. Okay. Can we try this one now? If I do 4 and draw it, there it is. Let's try 14. Very good. Okay, so that's how we draw a square of squares. Good job.